Hi, my name is John Seavey, and I'm going to teach a quick lesson on pressure altitude. The main reason that we as pilots need to understand pressure altitude is that because with pressure altitude and outside air temperature, we can calculate density altitude. And density altitude is important because it tells us our aircraft's performance. So pressure altitude with outside air temperature gives us density altitude. And density altitude tells us our performance. We'll talk about what exactly performance means for a helicopter in Lesson 5. For now, we're going to start with some definitions. We'll talk about standard pressure values, and then we'll go into pressure altitude itself. First, some definitions. Pressure is the weight of all of the air above us pushing down and pushing all around us. So, pressure is the weight of the air above us. And it's measured in inches of mercury. There's an average pressure, or what's called a standard pressure. The standard pressure value is 29.92 inches of mercury, or 29902. As you go up, there's less air above you, and so there's less pressure. There's an average amount that pressure decreases as you climb, which is called the standard pressure lapse rate. And that is 1 inch every 1,000 feet. If you go up 1,000 feet, the pressure will decrease by 1 inch on average. So, the big definition. What is pressure altitude? Pressure altitude is your height above the standard datum plane. The standard datum plane is wherever the standard pressure is found, 29902. Normally, standard pressure should be found at sea level. But as we know, if you ever watch the Weather Channel and you hear that a high pressure system is moving through or a low pressure system, you know that pressure changes. So it's not always standard. Let's look at this in a different way now. We're going to start at sea level. There's the ocean, and this is sea level. There's some land, and here's our helicopter. Right now, let's say that our helicopter is 1,000 feet above sea level. Altitude above sea level we call true altitude. Here, let's say that our true altitude is 1,000 feet. Above sea level. As we said, on a standard day, the pressure at sea level is 29902. Let's call it a standard day. And here we find 29902. Now, if you go up 1,000 feet, what would the pressure be there? We lose 1 inch every 1,000 feet on average. So it's going to be about 28.92 inches of mercury. Now this would be on a standard day. As we said, it isn't always standard. So let's say that on the Weather Channel we heard that there's a high pressure system moving through. And on this day we find out that sea level pressure is 30.42. It's a little bit above standard or higher than normal. Now we want to find out what is our pressure altitude. Knowing this, we can figure out about where the standard datum plane is, or where would 29902 be found. If the pressure at sea level is 30.42, then would 29902 be above it or below it? Right, pressure decreases as you go up, so 29.92 would be somewhere above it. But how far above it? Well, then we can use the standard pressure lapse rate again. Let's find the difference between this and standard pressure. If we take 30.42 minus standard pressure, we find there's a 0.50 difference. If 1 inch is 1,000 feet, then half an inch would be half that, or 500 feet. So, standard pressure, or the standard datum plane, 29.92, would be found about 500 feet above sea level in this case. Here's 29.92 on this day. Then we can figure out how high we are. If 29.92 is 500 feet above sea level, how high is our helicopter above the standard datum plane? Well, now it's only 500 feet above the standard datum plane, and that's what we call our pressure altitude. Let's look at one more example. Let's look at the opposite case of a low pressure day. Now the weather's getting worse. It's probably rain on the way. And the sea level pressure on this day is 29.82. Where would 29902 be? Above it or below it? So 29902 in theory would be down here somewhere. But how far would that be? Again, we'll look at the lapse rate and let's find the difference. The difference between these two is only 0.10. So again, if 1 inch is 1,000 feet, then 0.1 inches would be 100 feet. So 29902 on this day would, in theory at least, be 100 feet below sea level. So it adds to our true altitude. In this case, our pressure altitude would be 1,100 feet. Now, if you're mathematically inclined, take your standard pressure, subtract the sea level pressure, times 1,000, and add that to your true altitude, plus, and that will give you pressure altitude. So there are lots of ways to do it, lots of ways to look at it, but just remember, it's just this simple. Wherever 29902 is, your height above that is your pressure altitude.